Hello, guys. This is part two of our lesson on gases, and we would want to proceed by looking at the ideal gas. This is still your physics teacher, Sir Evans. So let's proceed with the lesson on ideal gas. An ideal gas is one assumed to consist of molecules that move randomly with no intermolecular forces of attraction or repulsion between the molecules, or better still, between the molecules and the walls of the containing vessel. And the molecules have negligible or no volume of their own. Now, all these collisions between the molecules are perfectly elastic. So we proceed now by saying that ideal gases are imaginary or hypothetical gases. All right, the ideal gases are imaginary or hypothetical gases, and all ideal gas say an ideal gas is a gas which obeys what we refer to as the gas laws. So any type of gas that obeys the gas laws, it is that type of gas that we refer to as an ideal gas. Okay, I believe that is clear. Now, we would have to know that the internal energy of an ideal gas is entirely kinetic energy. And this is because no force exists between the molecules. Okay. And this kinetic energy is the only internal energy. Yeah. The only internal energy of an ideal gas. And it depends only on its temperature. All right, let me explain that. You see, the kinetic energy of the gas molecules is directly proportional to its absolute temperature. I'm taking it again. The kinetic energy of a gas molecule is directly proportional to its absolute temperature. All right, and any gas behaves as an ideal gas if its density is very low. So gases whose density are very low always behave as ideal gas. This requires, in effect, the pressure. This requires, in effect, that the pressure is very low. Okay, and its temperature must be relatively high so that the gas is not close to the condition under which it condenses into a liquid. I'm taking it again. I'm saying here that when the pressure of a gas is very low, the temperature of that gas must be relatively high so that the gas in question is not close or does not get close to the condition under which it condenses into a liquid. Now, most gases at room temperature and atmospheric pressure can be regarded as ideal gases. All right, so now let's move to the gas laws. All right, please don't forget that I mentioned earlier that any gas that obeys gas laws is termed as an ideal gas. Okay, now that is why we are looking at the gas laws now. All right, now here at this level, we are expected to discuss three gas laws. One, the Boyle's law, Charles's law, and finally the pressure law. But before we come to that, we have to know that the gas laws are concerned with the relationship among the macroscopic measurable properties of a gas. All right. So, what are some of the measurable properties of a gas? Say the absolute temperature of a gas, the volume of a gas, and the pressure of a gas. These are measurable properties of a gas. And these three are what the gas laws are concerned with. Gas laws are concerned with the relationship between absolute temperature, the volume, and the pressure of a gas. Okay, now the pressure of a gas is a measure of the number of collisions made per second on the walls of the container. I'm repeating it for the last time. I'm saying that the pressure of a gas is a measure of the number of collisions made per second on the walls of the containing vessel. All right. And the gas laws, I've mentioned them, and we're going to start or begin by looking at the first one, which is Boyle's law. Okay, guys, I believe that Elsina is part of this lesson, and Mark as well. If they are not, please get them involved. Um, let's proceed. We are looking at Boyle's law now. Boyle's law normally deals or is concerned with the relationship between mostly volume and pressure. Okay, so say for a given sample of gas, the pressure, the volume, and the temperature are all related. Now, this man, Robert Boyle, was the first to investigate the effect of pressure on the volume of a gas at constant temperature. So that is why basically his name is assigned to it, Robert Boyle or Boyle's Law. So the investigation established one of the laws describing the thermal behavior of gases. So, by law, we say that Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume if the temperature remains constant. I'm repeating it again. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume if the temperature remains constant. So if we are not forgotten our dimensional analysis, we would say that by this law, the pressure is inversely proportional to volume. All right. And I believe that by taking away the proportionality sign in accordance to dimensions, we know that our pressure is now equal to K, which is a constant, times the inverse of the volume of the gas molecule. So pressure now is equal to K over the volume. And this K is our constant. So the constant by proportion is now equal to the product of the pressure and the volume of the gas. This is basically Boyle's law. Thank you so much for your time, and we're going to continue with this session in the next video in part 3 of gases. God bless you all.